version of h of t is gradually moved over this x of tau, and the overlapping regions are get multiplied and summed up. So this multiplication is nothing but the multiplication, and the integration is representing the summation. So that means what are the steps involved in case of convolution? Yesterday in last class we have discussed that there are some 5 basic steps that is involved with the convolution process. The first step represent the converting both x of t as well as h of t into a function of tau that is equal to x tau and h tau. Then one of the signal, either x of tau or h of tau, is get folded. That means 180-degree rotation. That means we are rotating, or that is known as folding. So after folding, we are finding the edges of the folded signal. One is called the left edge, that is called your right edge, another is your left edge. Then this folded signal is gradually shifted over the unfolded signal, and we are calculating the multiplication. After the multiplication, we are calculating the sum of product. After computing the sum of product, we are basically assembling the different sections that we have discussed in last class, that what exactly this convolution is doing. So that means in case of a convolution, basically we are calculating the folding, shifting, multiplication, and the sum of product. Then we are calculating the assembly, or we are getting the assembly. So in last class we have discussed about this problem that is equal to convolution of 2 signals. In this case there are 2 signals has been taken. One is x of t, another is your h of t. So both x of t and h of t are nothing but your continuous signals. They look like some rectangular waveform. So imagine that there are 2 rectangular signals are present like this, and we have to find the convolution of these 2 rectangular signals. When we have to find the convolution of these 2 rectangular signals, basically we landed into a trapezoidal waveform. So this is the trapezoidal waveform. How we got the trapezoidal waveform, that we have discussed in the last class. So in this case we have seen, once again I am just showing the physical significance of this. You can look into my camera, then you can easily understand. I'll just show what exactly is happening in this case. So suppose this is a rectangular signal, right? Now we'll take another rectangular signal like this. This is another rectangular signal. Now imagine what exactly is happening. So both the signals are like this. So now what I will do, I will rotate one signal by or folded it. So after folding, what is happening when this signal both are at separated, that means wide separated from each other, there is no overlapping. So that means there will be multiplication will become 0. Now what will happen gradually when it will touch, and it will gradually move. So what will happen? A portion of this signal and this signal are get overlapped. So as they are getting overlapped, so what will happen? Basically the signal will increasing with respect to, the response will increasing with respect to time. At this point there will be a complete overlapping. So that means you will get the maximum value, and again this complete overlapping will occur up to this point. That means extreme boundary of this signal. Then after that what will happen? Again there is a partial, as it will crosses over this, again there is a partial overlapping. I hope it is clear to you. So again it will continue, and when it will cross over this, then there will be no overlapping and it will give rise to 0. So this is the idea that what exactly is happening in case of convolution. I hope it is clear to you that what exactly is happening in case of your convolution. Now we'll come to, so this is happening. So gradually when there is, in this case that is region 1, there is no overlapping. So that means your convolution output is equal to 0. So as the signal that is equal to h of tau is moved over this x of tau, then there will be some partial overlapping occurring in this region 2. So due to region 2, as there is a partial overlapping, the signal is gradually increasing with respect to time. So that means this is a linear signal. Then next, as the signal is completely over this x of tau, then there will be a complete overlapping in region R3. Then we are getting this constant value, that is yt is equal to 6. Again, the signal is crosses over this extreme right region of this x of tau. Then there is a partial overlapping, and gradually this signal decreases, which is represented as minus 60 plus 18, where this minus represents the negative slope, and there is a y-intercept that is equal to 18. right? So as in case of region 5, so what will happen, this h of t is completely crosses your x of t, so there is no overlapping, so this will give rise to 0. So that was we have discussed about your convolution. I hope any doubt, anything you want to ask, you just please ask me. The same thing is happening in case of your discrete domain also. Now I am giving a very another some few points I want to tell about this convolution. So in this case, we have taken xt is the input, ht is the system response, or that is known as your impulse response, ht, and yt is equal to the response of the system, that is equal to yt. So now, if ht is equal to 0 for t is less than 0, suppose you will consider a system which is nothing but equal to 0 when t is less than 0, and that system is called your causal system, right? Already we have discussed that is equal to system is causal, right? So in that case, what will happen? What will happen to the limit? So as ht is equal to 0 for t is less than 0, so that means if we rotate the signal, so what will happen? You can get the signal from 0 to minus infinite. Are you getting my point? So now in this case, what will be your yt? Yt is nothing but minus infinite to t, x of tau, h of t minus tau. You understood this point? So that means why this integration is minus infinite to t. Now, if the input is causal, that means xt is equal to causal. If input is causal, that means I can say xt is equal to 0 for t is less than 0. So as this is equal to less than 0, so what will happen to this? As we are rotating your h of t, so this is nothing but 0 to minus infinite. So now xt is extended from 0 to infinite. So that means what will be your limit of integration? In this case, your limit of integration is equal to 0 to infinite x of tau, h of t minus tau. Now, if both xt and ht are causal, that means xt is equal to 0 for t is less than 0, ht is also 0 for t is less than 0. Then what will be happen to your this integration? This integration will become equal to 0 to t, x of tau, h of t minus tau. Anybody has any doubt? Please tell me. So now we'll see some more examples. Just I want to show you some 2-3 examples on these convolutions. Just let me open my whiteboard. So we'll just see one example of this convolution from your book, that is equal to signal system, which I have shared with you, that is Alan Oppenheim. Yeah. You can see your page number, that is 2.3, right? So in this case, if you look into your example 2.3, that is equal to xn, which is given in discrete domain, that is equal to alpha to the power n u of n, and hn, which is given, that is equal to u of n. So in this case, it is given that alpha, the value of alpha is equal to 0, is less than alpha less than 1. That means the value of alpha is lying between 0 to 1. So now you have to determine what is the convolution output in this case. So can anybody tell what will be the value of this case? Yes, just look into your book and think of and tell. Okay, I am directly opening the book. Yeah, it opened. Yeah. So now just to see here. So what is this thing is given to us and what we have to find out. So in this case, it is given xn So I can write that is equal to x of n is equal to alpha to the power n u of n. Try to understand it very carefully. And h of n is given that is equal to u of n. So before determining this convolution output, we should know what is this signal look like, alpha to the power n u of n. What is the value of alpha? Alpha is given that is equal to, it is in the range of 0 is less than 1. So that means its value is lying between 0 and 1. Right? Suppose alpha is equal to half. Suppose I have just considered alpha is equal to nothing but your half. So that means it is equal to 0.5. Now when 0.5 is get multiplied with u of n, so what will happen? What is u of n? U of n is nothing but, I will just make it, u of n is nothing but unit of step signal and which is in discrete domain. Am I right? So that means for n is equal to 0, value that is equal to 1, n is equal to 1, you are getting a value, n is equal to 2, you are getting the value, n is equal to 3, like this. So that means it will go up to infinite. So that is equal to nothing but your n. So this is equal to u of n. Now when I will multiply 0.5 with this, so what will happen? So that means this value will reduce to 0.5. So instead now it is 1. So now it will become equal to 0.5. So that means at 0 its magnitude will be 0.5. At 1 its magnitude will be 0.5. At 2 its magnitude will be 0.5, like this. I hope it is clear. So this I can write 0.5, or that is equal to alpha to the power n. Alpha is equal to nothing but half, 0.5. 0.5 into to the power n. Sorry, I have made a mistake here. So alpha is equal to 0.5 to the power n. N is equal to, in this case, 0. So I have made a mistake here. So alpha to the power n. Alpha to the power n means 0.5 to the power n. So that is equal to how much? So 0.5 to the power 0, that is equal to 1 un. So its magnitude at n is equal to 0 will become equal to 1. So at n is equal to 1, so what will be the value? So this is equal to n is equal to 1. This is n is equal to, n is equal to 1 means 0.5 to the power 1. 0.5 to the power 1 is equal to 0.5 into 1, that will become equal to 0.5. So this much is the magnitude. At n is equal to 2. So if we will take n is equal to 2, so this will become equal to 0.5 to the power 2. 0.5 to the power square is equal to nothing but your 0.25. So 0.25 into 1. So this will become equal to 0.25. Again, it will be reduced. Again, alpha, so when n equal to 3, so that is equal to nothing but your alpha, 0.5 to the power 3, that is 0.5 into 0.5 into 0.5. So that is equal to 0.125 into, that is equal to 1. So this will become equal to, so that means the signal is gradually reduced. So this value is nothing but your alpha to the power n into u of n, right? So now try to understand it very carefully. What exactly is happening in this case? Now what is hn? Hn is equal to nothing but your un. So what is un? How we can represent un? Already I have represented in this past figure that how it will be looking like un. So now what we have to do? We have to just rotate one signal, or we have to fold one signal, right? Suppose I will fold this u of n. If I will fold this u of n, then how it will look like? So that means so n is equal to 0. So I will just fold it. So then n is equal to -1. I will get the value. N equal to -2, I will get the value. N is equal to -3, I will get the value. So this is the value I will get. So that means I will fold one signal. So this is equal to h of n, that is equal to u of n. So I have folded it. So that means if I will fold, how much you will get? That is equal to nothing but your, I can say that is equal to u of -n. Am I right or not? Please tell me. So in this case, two things we have to do. So first we got xn, that is equal to alpha to the power n u of n. So this I can write, this is equal to nothing but your x of n. This is equal to nothing but your, how much it will be? This is equal to h of -n. Right? So before folding, just I have to convert this into some other variable for simplicity. So now I will make it to x of k If I'll make it to x of k, so this is equal to nothing but your alpha to the power k into u of k. Now this is equal to, I have to also make to another variable that is equal to some other variable k, so that is equal to u of minus k into that is equal to h of minus k. So now after folding, so what we have to do, we have to basically move this folded signal over the unfolded signal. So now this is equal to n is equal to 0, this n equal to -1, -2, -3 like this. So it is continuing up to infinite. So that means what will happen in this case, if we look into both the signals are nothing but causal. So that means for t is equal to less than 0, this value is 0. For this u of n, that is equal to t is equal to 0, this value is also 0. According to the principle, so what will happen to the convolution output? Your convolution output will become equal to, that is equal to yn. I can write that is equal to summation n is equal to minus infinite, or I can take n is equal to minus infinite to infinite x of k into h of n minus k. This is the similar way that I have written in case of your continuous domain. Just yt is equal to integration minus infinite to infinite x of tau into h of t minus tau. Just look at here. In this case, your input signal is xt. In this case, this system response is equal to ht. In this case, the input signal is x of n, and this system response is your h of n. Just I have correlate both the things, right? So as both are causal, so now what will happen to this case? In this case, it will become equal to how much? I can write that is equal to y of n is equal to summation n is equal to 0 to some value, or I can say some another value. Why I will take n is equal to 0? Because x of k is equal to nothing but your alpha to the power k u of k. So that means I can write 0 to infinite alpha to the power k u of k is equal to nothing but 1. So I can write simply alpha to the power k into this is equal to nothing but 1. So that is equal to alpha to the power k. So infinite means this value I can take some bigger value, that is equal to n is equal to 0 to some another big value, that is equal to n is equal to 0 to some capital N, as in case of previous case. Look at this slide. In this slide we have told when both the signals are causal, so that is it will become equal to 0 to t x of tau h of t minus tau. The same we will write that is equal to 0 to n, that is equal to alpha to the power k. So already you know that n is equal, that means this value of k, I can say what is the value of k? So the k is equal to nothing but in this case I have made a mistake. This is a mistake here. That is equal to tau. This will be d tau. Tau is varying from minus, so this is equal to k. K will vary from minus infinite to infinite. So this will be k. So k is equal to 0 to infinite. So this will become equal to k is equal to 0 to n alpha to the power k. So now this is a series representation. That means what will be the value of this? That is equal to 1 minus alpha to the power k plus 1 divided by 1 minus alpha. So now this is nothing but the convolution sum of these two signals. Anybody want to ask any questions? Please ask me. Right? How this is happening? Now, what will happen? So if we'll find the response graphically of this system, then how it will look like? So graphically your y of k will look like something like this. So that means when n is equal to 0 in both the cases, that will give rise to our 1. From 1 it will start like this. So that means I can say as it is a discrete signal, for n is equal to 0 it will be value of 1, n is equal to 1, again it will increase, again n is equal to 2, it will again increase, n is equal to 3, it will again increase, 4 again increase. So that means this will follow a shape like this. So that means it will continue, right? Anybody has any doubt, please tell me. So this is the thing that is given in your example. You just see here how it is happening in case of this. Anybody has any doubt, please tell me, ask me.
Sir, the last graph is y of n, sir?
Yeah, this last graph is equal to nothing but your y of n.
Sir, if both are casual, how we are changing the summation to 0 to infinite, sir?
Correct. If both are summation, how we are changing into. Now look at this concept. Imagine this is one signal, and that is from varying from 0 to some value.
Yes, sir.
Right? Now this is another signal. Clear?
Yes,
This
sir.
is also varying from 0 to some value. Right?
Yes.
So that means both are causal. Try to understand it very carefully. Now what I have to do, I have to fold one signal by 180 degree, or that is equal to rotate it by 180 degree. Suppose I have just to fold this signal by like this. Are you getting my point?
Yes, sir.
Clear? So now what we have to do, we have to basically move this signal over this signal. Try to understand. Now, how this integration is starting? So that means when both the signals are not overlapping, there is no, that means their multiplication will be not equal to 0. Are you getting my point?
Yes, sir.
Now, gradually this folded signal is moved over this unfolded signal. When it will touch, what will happen? Basically, the folding, that means the overlapping region is only this portion. Are you getting my point? So this is the portion which will get overlapped. Right? So it will represent in terms of your integration. Then how it will be 0 to t. Are you getting my point? So this is equal to 0. This will take some value of t. So now what will happen? The calculation that you have to find, it is from, that means if both that means it will be gradually overlapping and it will be moving over this. So that means 0 to t, it will give the summation that will be the value. Are you getting my point? So that means 0 to t. Integration of output. I hope it is clear to you.
Sir, when for any function, it will be 0 to t. What?
It will be from 0 to t. Any function is 0 to t. Right? Suppose I have a signal like this. Right? Suppose your x of t be like this. This is equal to 0. This is the x of t. This cover less than 0 also this is a signal which is not about something like this. Right? So this is also not so when you just do this expression, that means it's holding the expression of this signal. In this case, this signal after holding, it will be something like this. Are you getting my point? So this bus part from this side and this bus part from this side. Right? So now what will happen when you just do this some calculation in this when it is overlapping regions. So overlapping regions is not from 0 to t. It is minus something like to like.
Yes, sir.
Are you getting my point? So that is the thing. So it will become minus. So it will not always 0 to t. So that's why in the slide I have shown if both are that means if it is equal to causal, that means only the system response is causal, it will be minus infinite to t. If xt is causal, that is input is causal, this will be from 0 to infinite. If both are causal, it will be from 0 to t. So how you can realize it more clearly? That is just take some few examples and try it by yourself.
Okay, sir.
So just I'll give some 2-3 examples. You can do it and you can really understand what exactly is happening. Suppose you will take the case of your discrete signals. So suppose your xn is equal to like this. In one cases, I will take your xn is equal to 1, 0, 1. So that means this is the representation. What does it mean? It means that means it is a discrete signal whose value is equal to 1 at n is equal to 0. At n is equal to 1, its value is equal to 0. And n is equal to plus 1, its value is equal to plus 1. Am I right? So that means we can see that in this case your xn is equal to 0. At 0 its value is equal to 1. At n is equal to 1 its value is equal to 0. For n is equal to 2 its value is equal to 1. Are you getting my point or not? So that is equal to 0, 1 and 2. Right? So now this is signal is causal because for t is less than 0 there is no value is existing. Now you take another signal that is equal to h of n, which is also causal. Suppose your h of n is equal to 1, 1, 1. Right? So now h of n will become equal to how much it will be if you will represent it graphically. So for n is equal to 0 its value is 1. For n is equal to 1 its value is equal to 1. For n is equal to 2 its value is equal to 1. So that means I can say this is equal to n is equal to 0, n is equal to 1, n is equal to 2. It's all the values are 1. So now both the things are causal. So now you can see what is the convolution output. Suppose I will take this is equal to h1n, right? So now suppose I will take h2n is not causal. So h2n is not causal means I will take something like this 1, 1, 1, 1, 1. So 5 ones I have taken, and in this case your origin is at here. That means at origin is here means this is n is equal to 0, this is n is equal to 1, this is n is equal to 2, this is n is equal to minus 1, this is n is equal to minus 2. So now you can see what is the convolution between x and h2n. Just do it. Then similarly in another case you just take another x of n, that is equal to, which is also not causal. How will you write it? So that is equal to something like this. So that is equal to 1, minus 1, then 0, then you can say plus 1, minus 1. So in this case, if I will take your origin at here, again this is not causal. So if it is not causal, now you just calculate what is the convolution between these two. Then you can easily understand how these limits are basically changing when the input is causal or the response is causal, that is equal to h of n is causal or not. Right? You can able to find these limits for in case of your convolution. Anybody has any doubt? Please tell me.
Sir, how do we know where is origin, sir?
Wherever the arrow is present, that is known as the origin.
They'll give that. Okay, sir.
Yeah, wherever the arrow is present, that is known as the origin, and the right hand side is known as the positive x-axis, and the left hand side is known as the negative x-axis.
Okay, sir.
Right? Just try to do one thing so that at least we can understand that really beauty of this convolution, that what exactly is happening in case of your convolution. And remember one thing, one point in your mind, this convolution is applied for zero state. Have you studied zero state in case of network theory? It can be only applied for zero state, right? Whenever there is some initial conditions are there, you cannot able to find the convolution. Try to understand this point. Why you cannot we find out? You just think of and tell to me. You have studied. So today, what is the experiment that we? They have completed one.
Today, last they have asked them doubt. They completed today.
Second.
Code is great.
Code is there.
Only photos are
No, I have not sent the photo. You send the photo. Okay, this is convolution. Yeah. It is there. Not sent to send. Yeah, it's there. So tell them to send. Okay, I will join after some time. Yes. Anybody has any doubt? Please tell me. Now, if you don't have any doubt, you just see. There is a question given in your book, that is example 2.2, right? In that case, there are two graphical way it is representing how this convolution outreach computed, right? Let me show it from the book here. Let me open the book. Yeah, it's opened already. Yeah. So page number 7082. Not, so this is 87. Yeah, see, this is the this is the problem. Just a minute. Here it is. Yeah. Yeah, look at here. This is your x of k, right? This is your h of n minus k. That means at some different location it is present. There is no overlapping. So that will give rise to your 0. So now this is h of 0 minus k, right? So that means look at here. So now when I'll perform the multiplication, there is overlapping regions, right? Again it is giving a move to here, that is equal to h of 1 minus k. Again it will move towards the right, h of 2 minus k, h of 3 minus k. When it will cross completely over this n minus k, there is no overlapping, right? So this thing you just look at your book, that is page number 82. Next, this problem I have solved, that is example 2.3, xn is equal to alpha to the power n u of n. and hn is equal to u of n. So this is how it is looking like, that is alpha to the power n u of n. So at n is equal to 0, its magnitude is equal to 1. As n is gradually increasing, this magnitude is gradually decreases, and the value of alpha is given less than, that means lie between 0 to 1. So I have taken half for simplicity and calculated this value. And what is h of n? That is equal to u of n, whose magnitude is equal to 1 throughout from 0 to infinite. So now after convolution, yn is equal to k is equal to 0 to n alpha of k. So this is the thing that you got. So this is the value that is equal to y of n is equal to 1 minus alpha to the power n plus 1 divided by 1 minus alpha. Now what is this value? When n will become equal to 0, so this will become 1 minus alpha by 1 minus alpha. So that is equal to nothing but 1 minus alpha by 1 minus alpha. This will give rise to 1. So if you look at this expression, so this is at n is equal to 0, this value is equal to 1. For as n is gradually increases, so what will happen? It will increase, and certain value of n, it will become equal to constant. It will not increase, right? So that means there will be not much difference. It will become equal to almost saturate. So just a thing, you got my point. So this is the way that how your yn is basically varying. And if you will see the graphical representation or graphical illustration of this, so this is your alpha to the power k u of k. Now this h of k is get folded, that is 180 degree or that is folded or rotated. So this is h of minus k. Now if h of minus k is like this, h of that is equal to minus 1 minus k. So here minus is not visible. So minus 1 minus k. So there will be no overlapping. We will get the output to be 0. As it will become 0. So at this point there is only one overlapping. So again, as we are moving towards the right, gradually this value increases, right? So this is the thing that is happening in this case, right? So this is the graphical representation is given. Next is your example 2.4. This is one example is given. Xn is equal to 1 for 0 to 4. That means at 0 its value is equal to 1. At n is equal to 1 its value is equal to 1. 2 is equal to also n is equal to 2 it is also 1. N is equal to 3 also it is 1. N is equal to 4 it is also it is 1. And for all other points that is equal to 5, 6 up to infinite, as well as that is equal to minus 1 to minus infinite, this value is equal to 0. So you can get the graphical representation of this x of n. Now h of n is given, that is equal to alpha to the power n, and this is varying from 0 is less than n is less than 6, and in this case the value of alpha is given, that is equal to 1. Look at this question. Value of alpha is given is equal to 1. Now just calculate what will be the convolution output for this case. This is a very important question is asked in case of examination, because this is alpha is equal to 1. In this case different intervals we have to consider, and for each interval we have to calculate what is the value it is we are getting. So how we will calculate this value? The same way as I have done in case of your slides, that means different regions. Right, the same way you have to calculate for different regions or different intervals what are the convolution output. Just try to solve this problem. This answer is given, so that's why I am not discussing it. Just the same way as in case of continuous we have calculated, the same way you have to compute this. Right, so for different regions you will get the different values. So that is written here, the different regions, or that is equal to intervals. Now example 2.5, if you will see, xn is equal to 2 to the power n u of minus n, and hn is equal to un. This is the similar question to that of 2.3. So just you can able to do it. There is no problem in this case. Next is called, so this is about your convolution. So this is the thing that we have discussed. Next, one more point we have to discuss, that is called your properties. In last class I have discussed all the properties, so need not to worry about this. This is the continuous domain of response, already we have discussed, right? So that is no point. So there is one problem here has given. I have already solved the problem. So now this is the example 2.8. You just see xt is equal to e to the power 2t u of minus t, and ht is equal to u of t minus 3. Now determine what is the convolution output. There is nothing difficulty here. You just try to solve it by yourself. Now here it is given the two formulas of that is a convolution in continuous domain as well as in case of your discrete domain. In discrete domain this is represented by k is equal to minus infinite to infinite x of k h of n minus k, whereas in case of continuous domain it is integration from minus infinite to infinite x of tau h of t minus tau d tau. So this is the two things that you just see here, and we have discussed all the properties of this convolution, that is commutative property, distributive property, as well as we have discussed some. Yes, tell. Yeah. Okay. Thank you. We'll just discuss in next class. Thank you. Thanks all.
Thank you, sir.
Thank you.
Thank you, sir.